Good evening, everyone. Myself Shantana Mundul. Today I'll be presenting our work titled Evolutionary Dynamics of Prey Aposematism within an Adaptive Framework. Here is the brief overview of this presentation. Moving to the introduction, aposematism refers to warning signals such as bright color, odor, sound, toxicity that drives predators away by advertising their unprofitability. There are three key biological mechanisms through which aposematism work. First is signal honesty. So most of the aposematic prey are genuinely toxic. Second is predator learning. Predator associates those aposematic signals with negative experiences and thus avoids such a prey in the future. And lastly, mimicry, such as Batesian or Mullerian mimicry. So, classic example of aposematism includes poison dart frog, skunk, Batesian mimicry of scarlet king snake, Mullerian mimicry of viceroy and monarch butterflies. So, aposematism is well documented. However, a key question remains: how does the evolution of aposematism helps in the long-term persistence and stability of the prey population? To answer that, we have combined ecological and evolutionary dynamics via adaptive framework. Here, we consider this prey predator model where predation follows Halling type 2 functional response and prey growth follows Shepard's recruitment function. Now, D is the degree of this parameter D is the degree of aposematism, that is the fraction of time a prey invests into aposematic behavior. For that, the predation rate is decreased by 1 minus D fraction, and also prey's resource acquiring abilities is decreased by 1 minus D fraction. By putting this into that model, we obtain our final model, which is this one, and all the parameters of this model are provided in this table. Parameter values are taken from the relevant sources. Now, see this D, which is the degree of aposematism, remains constant within the context of ecological dynamics. However, when we will move to evolutionary dynamics, it will continuously vary in the interval 0 to 1. Next, we have obtained the interior steady state ERP where both species coexist, and also derived the stability condition for the interior steady state. And figure 1 shows that interior steady state is indeed stable for the mentioned parameter set. Moving to the evolutionary analysis, we consider that the ecological dynamics has already stabilized at the interior steady state R star P star, and also D, the degree of aposematism, depends on the prey trait. There is a resident trait Q and the mutant trait R. Now the mutant trait firstly is slightly altered from the resident trait, and it appears in the resident at low density. Therefore, we have obtained the invasion fitness of the mutant prey. Invasion fitness is defined as the per capita growth rate of a mutant when the environmental conditions are set by the resident. Next, by using adaptive dynamical tool, we have obtained the selection gradient, and from there evolutionary singular strategies are identified by these two equations. Now this allows us to identify the singular strategies as whether it is convergence stable or continuously stable strategy or evolutionary branching point. Theorem 1 provides us the condition under which the singular strategy Q naught, which is obtained from the equation 2.1, is continuously stable strategy. Moreover, it can never be an evolutionary branching point. Theorem 2 provides similar condition for the singular strategy Q1, which is obtained from that second equation, and also Q1 can never be an evolutionary branching point. Also, theorem 3 shows that if the interior steady state is stable, then evolutionary suicide cannot occur for the prey species. So there are three necessary and sufficient condition. Although the first two holds, the second one involving the sign of certain derivatives is not satisfied in this case. Next, we consider particular form of aposematism function. First is the linear aposematism function. The example of it includes ladybird beetle. So in this case, Q can be defined as the redness of the beetle. So as the intensity of the redness increases for the ladybird beetle, the probability of avoidance by the predator also increases. Here we have plotted the PIP, and PIP shows that there exists a unique singular strategy. Also, the evolutionary bifurcation diagram confirms that the unique singular strategy is a CSS. We have also modified the linear aposematism function to include nonlinearity. By modulating alpha and beta, we can obtain concave, convex, concave, or convex, concave, convex type of functions, and all these cases provide us the same evolutionary outcome. Next, we consider a nonlinear aposematism function. Here we have taken Gaussian distribution. The example of it the example of it includes milkweed bugs. So these bugs aggregate and they display slow exposed movement on the milkweed plant. Now, for the when the exposure is lower, predator do not identify them. When the exposure is higher, there are some naive predators who will definitely attack them. So the best thing for the predator avoidance is the intermediate level of exposure. So we have also plotted the PIP in this case, and PIP shows that there may exist up to three singular strategies. Also, we have plotted the evolutionary bifurcation diagram, and it shows that there exists a pitchfork like bifurcation in the evolutionary dynamics. And lastly, the trait dynamics with respect to evolutionary timescale is plotted, and it shows that there may exist up to two stable states. So, in conclusion, there may exist bistability in the evolutionary dynamics. The singular strategies, which are CSS, can never be an EBP. Also, prey species remains monomorphic throughout its evolutionary history, and evolutionary suicide cannot occur for the prey species. And lastly, as a conclusion or as a future direction, we can say that the interspecies competition or the crowding effect are taken in the fecundity in our model. If we would have used it in the mortality, we might have obtained the same result. In that case, it would prove the robustness of our model. However, we might have obtained some interesting other results like evolutionary branching point. Here are the references of this presentation. Thank you.